We're looking at the accumulation phase of annuity, and this is where we start out at that zero balance and we build up to a future value. And whether we're trying to come up with the desired future value and calculating those payments that need to be made in at those regular intervals, or whether we're looking at the regular payments and trying to figure out what the future value is going to be after making those payments, the key is the compound interest again, and the compound interest taking into effect the changing balance. So that compound interest is still paid in, still added in at the end of every period. But again, the balance is not the same. The derivation of this formula makes sense, but it's a rather long process. The beginning of it looks very much like our compound interest factor, and that is just 1 plus R over N, where R is our rate per year and N is our number of periods in a year, and it is to the power of N times T. But we have to adjust for the fact that the balance is changing. That adjustment takes place. We're going to subtract 1. Remember, these are percents. What we're doing is subtracting 100%. So that is isolating the interest from the future value, the total value. Then that amount is divided by R divided by N. So I'll put parentheses around this whole thing. That is our compound interest factor. For that changing balance in the accumulation phase of an annuity. So let's take a look at if we know what the monthly payment is. So we have, or not monthly, regular payment. So we know that regular payment going in to our investment. And we want to know what that future value is going to be. The formula to find that future value is simply the amount of that regular payment times our compound interest factor for annuities. Now I'm writing this out not as a formula, but I'm writing it out as you would enter it into the calculator. Many textbooks will write this out in a fraction form. Well, entering that into a calculator is very difficult. So yes, we do need 3 parentheses here. 1 plus R over N, close parentheses, to the power of N times T, then minus 1, close parentheses, divide by, open parentheses, R divided by N, and then we close our parentheses twice. Let's take a look at an example of how this works. So we have Stacy invests $100 each month. At 9.1% interest. How much will Stacy have in 25 years? So using our formula, we're finding the future value. The payment amount is $100 per month times 3 parentheses, 3 open parentheses, 1 plus our rate of 9% is 9.1% is 0.091. Paid in each month, so N is 12 monthly. The power of 12 times 25 minus 1. Close our parentheses, divided by open parentheses. Our rate of 0.091 divided by N of 12. And we close those parentheses twice. So 100 times 1, 2, 3, 1 plus 0.091 divided by 12, close, to the power of, and my power input 12 times 25, I put that in parentheses. Now, many calculators, you have to do this. You have to use the right arrow to get out of the exponent, so make sure you know whether your calculator requires that or not. Minus 1, close parentheses, open parentheses, 0.091, divided by 12, close and close. And we get 113,997.16. So at $100 a month, Stacy in 25 years will have $113,997.16. Let's look at a similar example. Kim is 24 years old. If Kim invests $3,000 per year, each year, at 10.3% interest, how much will Kim have at age 67? So our first thing here, from 24 to 67, we subtract that out, it's going to give us 43 years. So for our formula, we're finding a future value. We want to know how much she'll have at the end. That's a future value. We have a payment of $3,000 times 3 open parentheses, 1 plus our rate is 10.3, so 0.103 divided by making the payment each year, so that's 1 period a year. So divided by 1 to the power of 1 times 43 years minus 1, close parentheses, divided by 0.103 divided by 1, close and close. Now some of you may have noticed, since it's once a year, a lot of those ones dividing by and multiplying by ones could have been eliminated, but we're going to leave them in there just for consistency. So at the end of that 43 years, Kim will have $1,943,437.61. So $3,000 a year for 47 years nets over almost $2 million, $1,943,437.61. Now the next step we could take with this would be to ask, find the total interest earned. To do that, we have to first find the total payments. The total payments is just the regular payment times N times T. N is the number of payments per year. T is the number of years. Well, this was $3,000 per year times once a year times 43 years, giving us $129,000 is the total paid in. So the interest is simply that future value minus the total payments. $1,943,437.61 minus $129,000. So $814,000. $437.61 is the total interest earned. Let's go the other direction now. Here we knew the payment that was being made in, and we found that future value. The next section is going to be looking at, if we know what that future value is going to be, finding what that payment needs to be to get there.